Let's talk about physical versus chemical changes. So here's how you can use this video. Throughout this video, there'll be slides that have green highlighted text on it. If you're using this to take a notebook, that's the important text that you can write in your notebook. Feel free to always write more. Now, there's also going to be blue text. These are questions for you to answer to practice the material or questions for you to consider. Now, throughout this video, there's going to be two codes. One's going to be a visual code that pops up, and one's going to be a verbal code said by myself. So they can appear in any order. They're just going to be three numbers. They're randomly generated. So pay attention and get those codes. So let's get started. So let's talk about physical changes. Physical change results in the same substance but with a different form. So here's some questions to consider for a physical change. Did it only change shape or size? Did it only make a mixture? Did it only change the state of matter? Can it easily be reversed? And this last one, is it still the same substance? Now I put an asterisk on this one because if you look at the parentheses, it says if the answer to this one is yes, it's always a physical change. We're making it's the same substance, right? And then I put this one, if the answer is yes to any of these, it is most likely a physical change. That last one is sort of the key, but any of these are good signs. Now there are exceptions, and we'll get to those. So let's take a look at these examples off to the right, and we'll ask this question, right? Why are the examples to the right physical changes? So melting ice. So here's how you can use these questions here. So let's just go down. Did it only change shape or size? Okay, yeah, so it did change shape. It did change size. I've got like this ice cube, and then it melts, and it just becomes a liquid puddle. Did it only make a mixture? We didn't mix anything with it. Did it only change the state of matter? Yes, we went from a solid to a liquid. Can it easily be reversed? So this one, this could go either way. What that means is like, yeah, I could easily get it back to the solid form by putting it back in the freezer. And this last one, is it still the same substance? The answer is yes. It's still water. It's still H2O. We just went from a solid to a liquid. This is a physical change. Let's look at the next one, chopping wood. So if you're chopping wood, right, you're about to like have a bonfire and you have some logs, you have an axe, you're going to split this wood. Great. You're going to chop it. Well, let's go down this list. Did it only change shape or size? Well, yes, we changed the shape and the size of the wood. Did it make a mixture? No, we didn't mix anything for this one. Did it only change state of matter? No, we did not go from a solid to a liquid to a gas or any of those. Can it easily be reversed? Not really. Right? Now let's look at this last one. Like I said, this last one's the one that's telling. Is it still the same substance? So yes, it is. It's still wood. I just chopped it. It's just taking a different shape and size. It is a physical change. Now the next one's very similar to chopping wood, shredding paper or like cutting paper. Yep, we just changed shape or size. We did not make a mixture, did not change state of matter. Can't really easily be reversed, but once again, let's look at this last one, the one that's telling. Is it still the same substance? Yes, it is still paper. Now this last one, mixing gray and green marbles. So did it only change shape or size? Well, not really. No, right? Did it make a mixture? Yes, we made a mixture. We mixed things together. Did not change state of matter. Can it easily be reversed? Well, yeah, I could probably do that. You could probably pick out the green and the gray marbles. And once again, this last one, is it still the same substance? The answer is yes, right? It's still just marbles. So now let's get to this one, right? What is a chemical change then? So a chemical change results in a different substance with different properties. So here are some questions to ask for a chemical change. Did it change color? Did it produce a gas or like a smell? Is there a new precipitate? So a precipitate is the solid that forms from a solution during a chemical reaction. You mix two liquids together, is there a solid forming somewhere in that mixture? Did it release energy as light, sound, heat? And once again, here's the last question that's telling. Did it create something new? If the answer to this question is yes, it is always a chemical change. So like I said, the first four of them, right, those, like, yeah, you can answer yes, no to some of these, just that doesn't tell anything, but that last one is the telling one. So let's take a look off to the right, and let's go over how to use these questions. So let's look at burning wood. So we're making a fire, right? We already chopped the wood. Now we're going to burn it. Did it change color? Well, yes, right? It's going to be burnt. Did it produce a gas, like a smell? Yeah, you can smell a bonfire. Is there new precipitate? No, we're not mixing things together. Did it release energy as light, sound, heat? Yes, that's what fire is. We're releasing that as like light and heat. And this last one, did it create something new? So once again, I'm telling you this is a chemical change. It did create something new. The chemical properties of that wood is different than what we started with because we burned it. We are creating something new. Let's look at the next one, a rotting banana. So did it change color? Well, yes. We started with yellow. Now it's going to be like brownish. Did it produce a gas or a smell? Yeah, after a while it will. Is there new precipitate? Well, we're not mixing solutions, so the answer to that one is no. Did it release energy as light, sound, heat? Not really. Now this last one, I'm telling you it's a chemical change. Did it create something new? The answer is yes. We're making something new. This one might be a little bit confusing because you might look at that and say, well, it's still a banana, right? It's just like brownish. It just smells differently. Well, really anything biological is going to be a chemical change, whether it's like something rotting, right? Like a banana, or even like digestion, right? We take in food, we're making something new. We're breaking those chemical bonds. We're turning it into like muscles or bone or just parts of our body. We're making energy. Photosynthesis, right? So those plants, they're taking in that carbon dioxide. They're taking in light. They're making oxygen, right? They're making something new. So really anything biological is going to be some sort of a chemical change. So now let's look at that next one, right? Mixing vinegar and baking soda. Did it change color? Not really. Did it produce a gas? Yeah, you could say that. It's definitely making something. It's releasing carbon dioxide. Is there a new precipitate? Not really. In this reaction, not really. Did it release energy as light, sound, and heat? Yes, you can hear this one. This is a fizzing noise. Now, last one, did it create something new? So I'm telling you it is a chemical change. So yes, we are creating something new, right? But this one's kind of hard to see because you kind of start with a clear liquid and end with a clear liquid, but those are going to be different, right? We did have a chemical reaction happening. Let's take a look at that last one. Fireworks. So did it change colors? Yes, right. Did it produce a gas, a smell? Yeah, you can smell that. You can smell that after they explode. You can definitely smell that odor. Is there new precipitate? Not really. Like, we're not really mixing anything together. Did it release energy? Yes, as light, sound, heat. And once again, I'm telling you it's a chemical change. Did it create something new? The answer is yes. We're making something new. We went through a chemical process there. So let's get some practice here, right? So I'm going to give you some examples, and I want you to tell me, well, whether it's a physical or chemical change, then explain why. So I have those questions off to the side here, right? So I'll just put these up here, right? And then I'll write whether it's a chemical or physical change next to it, and we'll talk about why. So cutting paper. Right, so we already went over this one with shredding paper. It is a physical change, right? It is a physical change there. And it's because, I mean, we're not creating something new. It's just changing form. Burning toast. So this one's a chemical change, right? If you look at these questions, that's a chemical change. We're making something new, right? In fact, almost everything in like the kitchen, if you're involving the, if you're involving like the oven or the toaster or the stovetop, we're making something new, like when you're baking something. Boiling water. Well, if we look at these questions, well, we're only changing the state of matter. We're just going from a liquid to a solid. That is going to be a physical change there. Dissolving salt in water. So you put salt in water, you mix it. Well, this one's just making a mixture. When you put salt in water, yeah, it dissolves, but there's no chemical reaction. We still have the same thing. It's just salt and water. This is going to be a physical change. Iron rusting. So you leave iron out, it turns that like a brownish color. So if you look at that, like, did it change color? That's the first one right off the bat. Okay, yeah, that's a good sign. Did it create something new? Now here's the thing. You kind of have to know what's happening when iron is rusting. So iron is basically reacting with the oxygen in the atmosphere and is forming iron oxide. We are making something new. That is a chemical change. Now, at this time, I'll go ahead and give you that verbal code. The verbal code is 442. Now, let's take a look at this one. This last one, I did this because it's a little bit tricky. Adding food coloring to water. So I did this one because I wanted to show you that the first four questions really, in each category, could really is just a good, helpful hint. But that last one is the one that determines, hey, is it a physical change or a chemical change? Adding food coloring to water. Well, you might look at this and say, well, the water changes colors. Doesn't that mean it's a chemical change? Well, no. Here's the thing. We're not creating something new. That one's a little bit tricky. That one is actually a physical change because I still just have food coloring and water. This is the same thing for like mixing paints. If you're mixing paints, like, yes, it does change colors, but it's not because those paints are reacting, right? It's because, well, it's just those pigments mixing. We're just making a mixture. It just so happens that they change color. So I'm going to go ahead and put up a few more here, right? So cutting hair, baking cookies in the oven, making a salad, mixing two clear liquids to form a yellow solid, food is digested, and photosynthesis. So I'll leave this up here for a little bit for you to practice. Just go down these questions and ask yourself and try to determine whether they're a physical change or a chemical change. So just as a final thought, remember there is too much unknown in the universe to take a break from learning. Get out there and question everything.